Today, we're going to explore the fundamental building blocks of our connected world: networking devices. For those of you in computer networking, this knowledge is invaluable. It will help you design more efficient networks, troubleshoot issues more effectively, make informed decisions about network infrastructure. By the end of this session, you'll have a clear understanding of how these devices work together to create the networks we rely on every day. Our main aim is to help you understand complex concepts in a simple way and make learning enjoyable. Before beginning, do you want to know a secret? The subscribe button holds the key to unlocking more amazing tech content. Like and share if you're in on it. We'll cover 4 key devices: routers, switches, modems, access points. For each device, we'll explore what they do, how they work, why they're important. Let's begin our journey into the heart of network infrastructure. Imagine you're sending a letter to a friend in another country. You write the letter, put it in an envelope, and then what? You need a whole system to get that letter to your friend: postal workers, sorting offices, delivery trucks, airplanes. Without this system, your letter would never arrive. Networking devices are like this postal system, but for the internet. When you send an email or watch a video, these devices make sure your data gets where it needs to go. They're the reason you can video call your grandma, play online games with friends, or work from home. Without networking devices, the internet as we know it simply wouldn't exist. Pretty important, right? Now let's meet our main characters. We have 4 key networking devices. Routers. Think of these as the traffic cops of the internet. Switches. These are like the sorting offices in our postal analogy. Modems. These are the translators between your home network and the internet. Access points. These are like wireless megaphones, broadcasting internet to your devices. Each of these plays a crucial role in getting data from one place to another. They work together like a well-oiled machine to create the seamless internet experience we're all used to. Let's zoom in and look at each one in more detail. Routers are the traffic cops of the internet. Their job is to direct data to where it needs to go. Imagine you're driving to a friend's house in another city. At each intersection, you need to decide which road to take. Routers do this for data. When you send an email, the router looks at the destination and figures out the best path for it to take. Routers also act as a barrier between your home network and the big, bad internet. They're like bouncers at a club, checking IDs before letting data in or out. Your home probably has a router. It's that box with antennas that your internet provider gave you. So how does a router actually work? Let's break it down. A piece of data arrives at the router. Let's say it's a request to load a web page. The router looks at the destination address, kind of like checking the address on an envelope. It then consults its map, called a routing table, to figure out the best path. Finally, it sends the data on its way to the next stop. Routers do this millions of times a second. For every piece of data that passes through them, they're constantly updating their maps to find the fastest routes, like a super efficient GPS. Inside, routers have a CPU to make decisions, memory to store their maps, and multiple ports to connect to different networks. Now let's talk about switches. If routers are traffic cops, switches are like postal sorting offices for your local network. Switches connect different devices within the same network, like the computers in your office or the smart devices in your home. Their job is to make sure data gets to the right device quickly and efficiently. Imagine a switch as a super smart power strip. Instead of distributing electricity to different devices, it distributes data. When you print a document, the switch makes sure it goes to the printer and not your smart fridge. Switches create separate lanes for data, so devices don't interfere with each other. It's like having your own private road to work. Let's peek under the hood of a switch. How does it know where to send data? When a device connects to a switch, the switch makes a note of which port it's connected to. It keeps a table of all these connections, like a receptionist knowing where everyone sits in an office. When data arrives, the switch checks its table to see which port it should send the data to. It then forwards the data only to that specific port, not to all devices. This is much more efficient than older methods where data was sent to all devices, causing traffic jams. Switches can handle millions of these operations per second, keeping your local network running smoothly. Some advanced switches can even prioritize certain types of data, like giving video calls the fast lane during rush hour. Now meet the modem, your gateway to the internet. The word modem stands for modulator demodulator. Don't worry about remembering that. Just know it's a translator. Modems are like interpreters at the United Nations. They translate between two different languages. On one side, you have your home network speaking digital. On the other side, you have the internet speaking analog, over cable or phone lines. The modem's job is to convert between these two languages, allowing your devices to communicate with the internet. Without a modem, your home network and the internet would be speaking completely different languages. You might have a separate modem, or it might be combined with your router in a single device. So how does this translation process work? Let's break it down. Your device sends digital data to the modem. This is like writing a letter. The modem converts this into analog signals. This is like translating your letter into Morse code. These analog signals are sent over the internet cables. Think of this as sending your Morse code message. At the other end, another modem receives these signals and converts them back to digital. This is like someone receiving and translating your Morse code back into a readable letter. This process happens in reverse for data coming into your network. This all happens incredibly fast in milliseconds. The speed of this process is what we call your internet speed. Faster modems equals faster internet. Last but not least, let's talk about access points. The reason you can use the internet while lounging on your couch. Access points are like wireless broadcasters for your network. They take the internet signal from your router and spread it around wirelessly. Think of an access point like a sprinkler for the internet. It takes the water data from the hose wired connection and sprays it all around. This is what creates your Wi-Fi network. When you connect to Wi-Fi, you're connecting to an access point. In many home setups, the access point is built into the router. But in larger spaces, you might have separate access points to extend the Wi-Fi coverage. Access points are the reason you can move around with your phone or laptop and stay connected to the internet. So how do access points spread the internet love? Let's see. The access point is connected to your wired network, usually through the router. It broadcasts a signal, your Wi-Fi network name or SSID, saying, "Hey, I've got internet here." Your device says, "Ooh, I want some," and sends a request to connect. The access point checks if your device is allowed. This is where passwords come in. If allowed, the access point assigns your device an IP address, like giving you a name tag at an event. Now your device can send and receive data through the access point. This process happens every time a device connects to Wi-Fi. Modern access points can handle many devices at once and use clever techniques to provide the best signal. Now let's see how all these devices work together. Imagine you're watching a YouTube video. Your phone connects to the access point Wi-Fi. The access point passes your video request to the switch. The switch sends it to the router. The router determines the best path and sends it to the modem. The modem translates the request and sends it out to the internet. The video data comes back through the same process in reverse. This all happens in a fraction of a second. It's like a relay race with each device passing the baton to the next. This teamwork is what creates the seamless internet experience we're all used to. Let's bring this all together and look at a typical home network. You have a modem connecting your home to the internet. Connected to the modem is a router creating your home network. The router often includes a switch to connect wired devices. The router also usually has a built-in access point for Wi-Fi. In larger homes, you might have additional access points or switches. All these devices work together to create your home internet experience. Understanding this can help you troubleshoot when things go wrong. No Wi-Fi. Check the access point. No internet at all? The problem might be with the modem. This setup allows all your devices, phones, computers, smart TVs, etc., to connect and communicate. Alright, let's wrap this up. Here's what we've learned. Routers are the traffic directors, guiding data between networks. Switches are the local organizers, managing data within a network. Modems are the translators, converting between your network and the internet. Access points are the wireless broadcasters, creating your Wi-Fi network. These devices work together to create the internet experience we know and love. Next time you're streaming a movie or video calling a friend, you'll know the behind-the-scenes magic making it happen. Remember, the internet isn't a cloud. It's a physical network of devices working hard to keep us connected.